I have every reason to celebrate today because, well, I did some programming. I've not really done programming in like 2 years. And today's special Raspberry Pi Pico. It's supposed to be insanely hard to program, at least for an absolute programming. I don't have the words for it. Well, so of course I cheated and used Python, whatever. This thing makes it so incredibly easy. Like I can just change one line of code, press the run button, and it's going to run instantly. So the code I have here today, which is like literally 27 lines, basically gives you a complementary square wave. I've set the processor frequency to 100 megahertz and I've set PIO frequency to 100 kilohertz. No, 1 megahertz. Yes, or was it 10 megahertz? It was 10 megahertz. So 3 clock cycles high, 3 clock cycles low, which is perfect. Timing is like crazy good. And I also managed to set up side set, which is not active right now. I also managed to set up jump pin, which jumps to another part of the program when a certain pin is high, which is what I will be demonstrating right now. uh, 0 1 2 3. So if I set pin 3 high, you can see that something happens. In this case, the frequency decreases by half, and the timing of, excuse me, of course, is perfect again. 1 2 3 4 5 6 clock cycles, and obviously 6 on the other side as well. Another interesting thing to note, if the processor frequency is not a clean multiple of PIO frequency, let me change it to the original clock frequency, you will get some weird timing errors. I think you can see the jitter on the edge. Yep, that wasn't there last time when we had a 100 megahertz clock. I think the effect will be more visible if I remove the pin. I mean, and now let me quickly change it back to 100 megahertz. Press run, and we got our perfect timing back. Well, I'm calling this an absolute win because I can finally finish this project on my own. Well, or so I hope. Let's see where this goes.